So Waleed, this is your heatsink project. Looks interesting. Tell me, what is special about this design? Yes sir. This is a fractal tree-type heatsink, and I designed all the branch sizes using Murray's law. Good. Start from the basics. Why did you choose a fractal design? Sir, fractal designs copy natural branching just like blood vessels in trees. They give better fluid flow, uniform heat distribution, maximum surface area and less space, so it cools the system faster. And where does Murray's law come in? Sir, Murray's law helps calculate the perfect radius of each branch. The formula is R0 cubed equals R1 cubed plus R2. This means the cube of the parent channel radius equals the sum of the cubes of the two child channels. Why the cube? Because flow resistance and energy loss change with radius, so using this law reduces pumping power and improves efficiency. Give me your actual project numbers. Yes, sir. When both daughter branches are equal, we simplify Murray's law. The formula is parent radius cubed equals 2 times daughter radius cubed. R0 cubed equals 2 times rad, so daughter radius equals parent radius divided by the cube root of 2. Rad equals R0/1.26 for my project. Parent radius is 3 millimeters. Both daughter radii equal 3 divided by 1.26, which is approximately 2.38 millimeters. This gives perfectly balanced branching for each level. Very good, Waleed. That is the correct formula for equal daughter branches. Exactly, sir. By following Murray's law at every level, flow becomes smooth, pressure drops, stays low, heat spreads evenly in all branches, cooling efficiency increases. That's why fractal heat sinks work better than normal straight channels. Excellent, Waleed. Your explanation is clear, and your calculations match the theory. This is a proper engineering-based project. Thank you, sir. I'll add these formulas and diagrams in my final presentation. Good. Looking forward to your full demo.